What I'm going to do now is have a servo motor connected to an Arduino and have that moving, and where I'm going to decide the servo motor to move is going to be using the input from a potentiometer. So let's have a look at the program. So what we've got is we have two signal pins. First one is A0, which is reading the potentiometer, and that's a number between 0 and 1023 depending on how far the potentiometer is rotated. The second pin, I'm going to use pin 9 as an output. That is going to be connected to the signal pin of the servo motor. So the servo motor requires 3 pins: ground, positive voltage, and this orange one here is a signal pin, which is connected to pin 9 of the Arduino. So we can see it's going into there. So it's actually connected to pin 9 through this interface shield that I have. Okay, just going back to the program. So in the main loop, I'm reading the analog pin A0, that's the potentiometer, number between 0 and 1023. I'm going to print it onto the screen as well in case I want to see it. And then the servo motor is controlled by a pulse. Now the pulse is repeated, has to be repeated about every 20 milliseconds. And it's the length of the pulse that determines the position of the servo motor, of its rotation. So the lowest value is 1 millisecond as a pulse length, and the highest position, or the largest rotation of the servo motor, will be a pulsing of 2 milliseconds. So anywhere between 1 and 2 milliseconds will determine where the servo motor has to rotate to. So what I'm doing here is a digital write to pin 9 high, so that sets it high. And then I delay in microseconds. So I'm going to use microseconds rather than millisecond. A microsecond is 1000 milliseconds. So delay microseconds, and I've got 1000, so that's 1 millisecond, plus the value that I read from the potentiometer, which is between 0 and 1023. So delay microseconds altogether in that bracket will be any number between 1000 and 2023. So it's between 1 and just over 2 milliseconds, so it should move at the same position as the input potentiometer. After that short delay, it then sets the pin low again, and then there's a delay of about 20 milliseconds duration. That's 20,000 microseconds. So what I'm going to do is program the Arduino. So just compile that, so it's uploading to the Arduino. To wait for the green line to go right across, that's fine. I'm also going to put in a serial plotter so I can see what's going on from the information from the potentiometer as I rotate this. So what we'll have here is, as I rotate the potentiometer, you can see the servo motor is following it exactly. So there's analog voltage from the potentiometer being read by the Arduino, which is turning that into a varying pulse length, which is then controlling the servo motor, and the reaction is pretty quick. And as I'm rotating this potentiometer, I can also see values on the screen as it's moving like that. So it follows my movement, and it's quite canny really, but it can move quite slowly or quite quickly.